welcome to the week of April 26th. It is the last week in April. Next week we will be in May, and that means that we are officially a month away from the last day of school. At this time, I want you to make sure you've got your math notebook out and you're ready to take good notes. That will help you when you go to do the assignments this week. And I do want to start with the warm-up problem that reviews the distance formula. So if you look up the warm-up problem, I want you to find the distance between point R that has coordinates -3, 4, and point S, which has coordinates 2, 6. To find the distance formula, let me try that one more time. To find the distance between 2 points, you will need to use the distance formula. So if you do not remember what the distance formula is, now would be a great time to do a web search. Quick Google. The reason we're starting with this as a warm-up is to review the distance formula because you will be using it this week. So we're going to jump right in with reviewing a concept that you've learned previously in math that you're going to use again this week when you're solving problems dealing with circles. So go ahead now and click pause and do this problem on your own, and then when you're ready to check your work with mine, go ahead and click play again. All right. So let's start with writing down the distance formula. So the distance formula is when we take the square root of and subtract your 2x coordinates. So your second x coordinate minus your first x coordinate, find the difference, square that difference. Add to it the same thing with the y coordinates. Subtract the second y coordinate, subtract the first y coordinate from the second and square those, and then add together those squares and take the square root. So let's go ahead and look back up at these points. Your first x coordinate is going to be right here. This would be your first y coordinate. The points in S, point S, are going to be your second coordinate. So your second x coordinate and your second y coordinate. So let's go ahead and plug those into the distance formula. All right, second x coordinate is going to be 2 minus our first x coordinate, which is a -3. So note that I will have a double negative there because we're subtracting the 2, and since we have a negative number, that gives us 2 negatives. And then we're going to take the second y coordinate, which is 6, and subtract it minus the first y coordinate, which is 4, and square that. So let's start working on simplifying now. When we have a double negative, it becomes a positive, so 2 plus 3 is 5, so we're going to be squaring 5 eventually, and we'll add to that 6 minus 4, which is 2, and we'll square that. So let's keep going. 25, I guess I gave that away. 5 squared is 25 plus 2 squared is 4, so we will get the square root of 29. And that's our most exact answer because there's not a square root, a perfect square for 29. So we're going to leave it just as the square root of 29 because that's going to be the most accurate answer that we can get. If we plug the square root of -29 into your calculator, you will get a decimal. So if we leave it as a square root of 29, we won't have to round that decimal. So it's going to be the most accurate answer there is. All right, I'm going to keep going here. If you need more time, go ahead and click pause now. All right, so this week we're going to complete 2 sessions. We're going to complete Unit 8 Session 6 with segment relationships in the circle, and then Unit 8 Session 7, which is the last session in Unit 8, and it's all about circles in the coordinate plane. Circles in the coordinate plane. Now think about the warm-up problem you just did. It dealt with coordinates. So you might see that we're starting to have a relationship here with what we're going to be looking at this week, which is circles in the coordinate plane. Now for the recording that I'm doing right now, it's going to be focusing on Unit 8 Session 7 because I find that students find this session most challenging. So I do want to spend the time in this recording to go over the concepts in session 7. So after you watch this recording and everything is fresh in your mind about Unit 8, Session 7, you might want to just complete this session assignment first and then go back and complete Unit 8, Session 6. It is okay to work out of order this week. You will be able to complete Session 7 before doing Session 6. So just a recommendation, you don't have to do it that way. All right, so again, we are about a month out from the last day of school, so be thinking about what you want your grade to be and where you are now and how you're going to achieve your goal end of the semester grade. Now is the time to be proactive. If you've got missing work, now is the time to be turning it in. I will be letting you guys know when the last day to submit late work is. Coming up here soon when I get all those dates locked down, but for now, just make sure that you're working hard on getting your missing work submitted, because I will have a date for all missing work to be done that is before the end of the school year, so that I have enough time to get all that graded. So just a heads up. All right, so Unit 8, Session 7, Circles and Coordinate Planes. So when we've got circles and coordinate planes, we have an equation that allows us to graph circles in a coordinate plane. Just like in algebra, where you guys learned linear equations like y equals mx plus b, that's the equation for a linear equation, and you knew you could graph lines based on that equation. The same is true with circles. And we have an equation just like y equals mx plus b. We've got an equation for circles, and that is this equation right here that I just highlighted. The equation for circles is, in parentheses, x minus h squared plus, in parentheses, y minus k squared equals r squared. And now let's talk about the different variables we're seeing in this equation. So x and y are just going to represent our x and y coordinates, just like we're used to seeing. H and k is a little different, isn't it new? So h and k are going to let us know what the center of the circle is. So h and k, when we see numbers for h and k, that's going to let us know what the center of the circle is. We will only substitute in numbers for h, k, and r, by the way, and all this will start making more sense. I know this is brand new, so just hang in there right now. So h and k are going to represent the center. So when there's numbers plugged in for h and k, those numbers will let us know where the center of the circle is. So I'm just going to put a number sign under there to let us know that there's numbers. And then r, so hk will be our center, and r is going to stand for the radius. R will equal the radius, r equals the radius. It lets us know what the radius of the circle is. So let's see if we can plug some numbers that represent the center and the radius into the equation. So we'll start seeing how equations are really going to look when they've got numbers in it. So if we have a circle that has the center with the coordinate 4, 6 and radius 4, what would the equation of the circle, that circle, be? All right, so let's look back up. The equation for a circle is going to be, in parentheses, x minus, it's always x minus. That minus is built into the equation for the circle. So since this, over here, let's look back over here, the center of the circle is at 4, 6. So 4 is the first number in our parentheses, so that for the center, so that means that's going to represent our h, and the second coordinate 6 is going to represent the k, and that represents our center of the circle. So coming back over here, the equation for the circle, again, is always x minus h. The minus is built into the equation. It's always going to be x minus. So h is 4, so I'm going to put 4 in there, and then I'm going to square it. And then I'm going to add to it y minus, and then I look to see what was my k coordinate value. It was 6. So I'll plug that in and square it. And then what is the radius? The radius is 4, so I'm going to write 4 squared. And that would be the equation for our circle. A lot of times you'll see the equation written as equals 16 instead. The 4 will actually be squared, and it will be written as 16. And we would be able to know that the radius is always represented by r squared. So the radius is going to be the square root of 16, which is 4. All right, let's look at this second example. If you want, you can go ahead and click pause and see if you can write the equation of the circle that has a center at 2, -3, with a radius of 2. And be careful with the negatives. Be careful with the negative. There's a -3 as our center, our k value. So remember, it's always y minus. So sometimes you might have a double negative. That's your hint. So if you want, you can go ahead and click pause and try this one on your own. Otherwise, let's go ahead and do it. So the equation of the line, it always we leave x as is, and then we write minus. So our center is at hk. It was given right here. Our h value is 2, so we're going to write x minus 2 squared. Add to it y minus -3. So here we had a double negative because the equation that we're working with for circles always has a negative built in to begin with. We've got x minus h, y minus k. So if you have a negative coordinate as your center, you're going to have a double negative. And then it will set that equal to 2 squared. So if we clean this equation up, we would, to fix that double negative, we know when we have a double negative, it turns to a positive, so it would be really y plus 3 squared equals 4, because I'm going to go ahead and square that radius of 2. So again, what I really want you guys to take away, since you're starting to, you've seen a couple examples of the equation for the circle being used, I really want you to take away the fact that there is a negative built into the equation for circles. It's always x minus the h coordinate and y minus the k coordinate of our center. And there is possibilities to have double negatives if the coordinate for a center is negative. All right, I'm going to move on, but if you need time to take notes, which I highly recommend, you need to be taking notes so that when you go to do this week's assignment, you've got some more examples to look at. All right, so now what if you're given the equation of a circle with numbers already plugged into it? Can you tell me what the center is and the radius is of the circle? Well, let's go ahead and do that. So remember, the equation of the circle is right here so that you can refer back to it, where h and k represent the center coordinates and r represents the radius. So the numbers are the important thing. Remember again that the equation for circles is always y minus h. It's not x plus h. It's not y plus k. It's minus y minus h and y minus k. Those negatives are built in. So what do we have here? What is our h and our k so that we can find the center for number 1? So here's our h and there's our k. So the center will be at +5 and +3. Again, those numbers are positive because that negative doesn't belong to the coordinates of the center, because it's always y minus h. That minus is just part of the equation for circles. So the center is going to be at 5, 3. What about the radius? So remember, our equation for circles is y squared, or I'm sorry, it's always given to us as r squared at the end. We set everything equal to r squared. So if we have 36, That's representing r squared. R squared equals 36. So what is going to be just the radius? So if we take the square root of both sides, that will give us what just the radius is. So the square root of 36 is 6. So the radius would be 6 of that circle. All right, I want you to look at number 2 and see if you can figure out number 2 on your own. So if you want to click pause and try number 2 on your own and see if you've got this down, go ahead and do so. Otherwise, I'm going to do this right now. So we've got x plus 2. Okay, that's a little different. Having a plus there doesn't match the equation of a circle because we know the equation of a circle is x minus. So we can rewrite that so that it has a double negative because we know a double negative equals a positive. So I'm going to rewrite that. Oops, I was missing the squares up here too. I meant to write those in. Those should be in there. Plus, I'm just going to rewrite this so that we've got it written with negatives. So I haven't changed the quantity because I know that a double negative is the same thing as a positive. So I haven't really changed. I haven't changed the quantity at all. So here's my h and here's my k. So the center of the circle then would be at -2, 7. So you just really need to be careful when you're writing the center coordinates and making sure that you're not accidentally, looking over here where we've got y minus 7 and saying that the center is at -7. Again, the equation for the general equation for circles is written as y minus, so that minus is built in. So we've got our center. What about the radius? Remember, the radius is always r squared. So if r squared equals 49, what times itself would give us 49? 7. So the radius would be 7. The square root of 49 is 7. So that's our radius, and that's our center. So you'll have to do that this week. You'll have to write the equation of circles given a center and a radius, and then you'll need to work backwards. If you're given an equation with the center already written into the equation, can you extract that? Just like we did here. All right. Here we've got a circle graphed on the coordinate plane. And your job now is to write the equation of that circle that's graphed. So you actually know how to do this already. You know the equation to use for a circle. So now all you need to do is substitute in the coordinates of the center and then what the radius is. So let's identify those things. So what are the coordinates of the center of the circle? What are the coordinates of the center of the circle? So the center is right here, right there, pointing at it. That's the center of our circle. So what are those coordinates? 1, 2. So the coordinates of our circle are 1, 2. What's the radius of our circle? So to find the radius, all you need to do is count how many boxes out from the center to the side of the circle. So I would choose a horizontal or vertical distance. Any horizontal or vertical distance from the center out to the side, and count the number of boxes. So if we go from the center out to the right side of our circle, we would count 1, 2, 3, 4. Let's check it. Let's go from the center to the top of our circle. 1, 2, 3, 4. Same thing. So the radius is going to be 4. The radius is going to be 4. So now we can just plug that information into the equation for the circle. So I'm going to remember the center is represented by HK. So I'm going to write in, okay, the equation for a circle is x minus h. Well, I know h is 1, so I'm going to put in 1 instead of h. And I'm going to square that. Plus, the equation of a circle is y minus k. Well, I know k is 2, so I'm going to substitute that in. And then radius squared. So 4 squared is 16. And that is our equation for this circle. I'm going to move on now, so if you need more time, go ahead and click pause so that you can write this example down. Okay. So here we are going to again write the equation of the circle given that circle M, so that means the center of this circle is going to be at point M, passes through this point, -4, 2, and has a center at 0, 1. Okay, so let's go ahead and plot this on a coordinate plane. Let's plot the given information. So here's our coordinate plane. I'm going to go ahead and plot the center first. It's at 0, 1 is our center. So 0, 1 is right there. And it passes through point -4, 2. So that means the circle has to be somewhere, it's going to look something like this. I'm just going to do it in dashed lines here. So it's got to pass through that point. So that means that point -4, 2 is going to lie somewhere on the edge of this circle here. It's going -2, 4 is going to be on the outside of that circle. So how do we write the equation for that circle? We know the center is is 0, 1, so we know our h and our k value for the circle. We know our h is 0 and the k is going to be -1 to plug into the equation for the circle, which I'll remind you is x minus h squared plus y minus k squared equals r squared. So we know the h and the k. Okay, that's good news. We can plug h and k into the equation for 0 and 1. So that's done. We just need numbers for the radius. So how can we figure out what the radius of the circle is? Well, that is when we get to use the distance formula. So that's why I'm going to move this all over a little bit. That's why we reviewed the distance formula today, so that we can use it now to find the radius of the circle when we're only given a point or the circle and a point that the circle passes through. So to find the radius, we need to find the distance between these 2 points. We need to find the distance between -4, 2 and 0, 1. We need to find the distance. So we reviewed the distance formula at the very beginning of this session for our warm-up problem. So we're ready to go. Let's go ahead and plug things in. So the distance, d for distance, is going to equal, so we plug in our second y value, which is 1, minus our first y value, which is 2, and then we'll square that. Add it to our second x value, or coordinate, minus our first x coordinate. So we're going to have a double negative there because the distance formula, we subtract our 2 y coordinates. So since we're subtracting, and then we've got a -4, that's why we have a double negative there. So this, again, let me check to make sure we did that right. Second y minus the first one, 0 minus the second one. We're good to go. Let's keep going. Let's simplify. 1 minus 2 is -1. We'll square that and add to it +4 squared. And what do we get? -1 squared is just +1 plus 4 squared is 16. Gives us a square root of 17. So that means our radius equals the square root of 17. That is our radius. Kind of running out of space there down there. So, you know, we're going to skip this next question. We're kind of running out of time, but so I just am going to kind of black that question out, and we'll just continue our work here. Okay, so we know that the radius is square root of 17. So now we're ready to plug things in, right? So we know, let's pull this down here and start substituting in our given information. So when I went ahead now and inserted, so here's our equation for a circle. The general equation for a circle is x minus h squared plus y minus k squared equals radius squared, where we know we're going to substitute in numbers for the center of the circle for h and k. And we were told the center of a circle was 0, 1. So 0 is going to represent the h, 1 will represent the k. So we would have x minus 0 squared plus y minus 1 equals our radius we discovered by using the distance formula was radical 17, or square root of 17. Square that. So I took out the negative minus 0. That's not going to change anything, so it's just going to be cleaned up as x squared. Then we still have that y minus 1 squared, and when we square the square root of 17, we get plain old 17. Because the square root of 17 times the square root of 17 equals 17. So this would be our final equation. This is going to be our final equation. So you will have a problem just like this on your homework this week, so make sure you take down this example because you will see a problem just like this in your homework this week. So make sure you copy this down. I'm going to go on to the next slide now, so go ahead and click pause if you need to continue copying this down so that when you see a problem like this on your homework, you have an example to refer back to. All right, so we're going to stop there, and I'm going to write down the key phrase assignment question. All right, so one more time, we are going to review what the equation for a circle is. So the general equation is x minus h squared plus y minus k squared equals r squared. And I want you to tell me, what do those variables h and k in that equation represent? And that's it. So the directions for completing the key phrase are below in case you need a refresher on that. Otherwise, you guys are good to go. Please make sure you wrote down the example that I just went over, that previous example, because you will see a question just like that on your homework. So make sure you did copy down that previous example I just went over in this previous slide. Have a great rest of your week, and let me know if you need help with anything.